Assalamu alaikum wa rahmatullahi wa barakatuh. We are continuing with inclined planes. And in our first lesson, just to recap, in our part one of inclined planes, we looked at calculating the average power developed by the Bucky's engine. And we used the equation power is equals to work over time. And we had to work out our net work and we had to work out our time using distance of velocity. And we said using that equation power is equals to work over time, we got our answer. And I see an error here that it wasn't watts, power is measured. Oh yes, power is measured in watts, so it's correct. So we got 2,38 times 10 to the power 5 watts. In our second lesson, we said we can do the same sum, but in this, what we can do is look at the forces that are parallel to the slope. And we see that there are two forces pulling the bucket down. The one will be the frictional force pulling the bucket down, and the second one will be the parallel component of weight. A very important diagram. This diagram is very important, and we use the equation P is equals to FV, and we have to work out sine theta, and then using the equation, we got an answer that was the same as the previous answer. And just when I double checked that, there was a small error where I didn't put in the value of the decimals, rounding off, always round off to two decimal places. So there was an error there was an error there, and there was a slight error there. But we see that overall we got the same answer. So if you are following closely, then you should just fix those two errors. But we see that the answer is the same. The rationale of doing the sum is very important. Now, going further, we see question 6.2 says, what is the resultant force on the bucket at the point halfway up the 750-meter climb? Explain your answer. So because the buck is moving at constant speed, we can say that the resultant force is zero. And this is explained according to Newton 1, where if we have an object moving at constant velocity, it means that the net force acting on the object is zero. And in this case, we can say that the force of the engine pulling the object up is equal to the force of friction pushing it down and the force of parallel component of weight pushing it down. So the upward force will be equal to the downward force, which makes it the net force being zero. Okay, well, that was 6.2. 6.3, the question is, after the bucket has been offloaded, its empty mass is 1,100 kilograms. On its return journey, the bucket accelerates from 72 kilometers at the top of the slope, 72 kilometers per hour at the top of the slope, to 90 kilometers per hour at the bottom of the slope. If the average frictional force of the bucket during the downhill journey is 6,44 times 10 to the 3, how much work does the engine do while the bucket is accelerating? Right, so just to convert, if you convert 72 kilometers per hour to meters per second, we get 20 meters per second. And if we take 90 kilometers per hour and you divide by 3.6, we get 25 meters per second. So that's very important. Now, to understand this question, I will just draw a little bit of a diagram here. We're saying here's your object at the top, the bucket at the top, and the bucket is coming down. Now, if you're using energy, if you're looking at the energy principles, you see that there was an increase in the speed when the bucket went from the top to the bottom. So your EK increased. It went up. All right. And then we see that the EP went down because your height was 55 meters and then you're coming to the ground. And we see that there was energy of friction which was required to be overcome by the engine. Now the question is, how much work does the engine do? Now the engine does work to increase the kinetic energy, and the engine does work to overcome friction. However, the engine doesn't do work to overcome potential energy. In fact, the potential energy because the bucket is going down, and we know that when you're going down the slope, we don't have to press the accelerator, because the fact that you're going down the slope shows you that you are being helped, so to say, going down the slope. So the potential energy is actually something that you don't have to overcome as you were going up the slope. In fact, you have to subtract it because you're going down the slope. So if you look at the energy done by the bucky, the engine, right? So if you look at the energy that the overcome had to be overcome by the engine, it will be your change in your kinetic energy, because there was an increase in your kinetic energy. It will also be the energy needed to overcome friction. And because you're going down the slope, your potential energy is actually helping the engine. So we have to subtract that energy that the potential energy gives to the engine. In fact, you can say it's just like, to rationalize it, it's like you saying that the potential energy is helping the engine go down the slope, or the potential energy is converted to kinetic energy, so it assists the bucky in going down the slope. So that's very important to remember. So the first important thing is to identify what are the energy changes that the engine has to do. What work does the engine have to do? Does it have to overcome kinetic energy? Does it have to overcome potential energy? Does it have to overcome friction? And this is the most important aspect in working out the sum. So let's continue. If we have to do the sum, let's get some space. Your energy change, your kinetic energy change will be a half mv f squared minus a half mv I squared plus energy of friction minus mgh. This will be a half. The mass of the bucket now is no more 1750. You must be careful. It's 1100. Your final velocity is 25 squared minus a half 1100 20 squared plus the engine has to overcome friction, which is 6,44 plus 10 times 10 to the power 3, and that is just the force. So therefore your energy is equals to force times distance. So actually we should do this. We should say is to fix our to be F times S. So it will be F times delta X. So your force is 6,44 times 10 to the 3 newtons, and then your distance will be 570 meters, and you'll have to subtract mgh. 1100 times 9,8 times the height. Potential energy is the energy that doesn't have to be done by the engine, so we subtract it because it's assisting the engine in overcoming all those extra work that it has to done, the extra work that it has to do. Sorry. So if we take our calculator and we work this out, okay, spending time with my calculator work, we see that we get our final answer of 3,2 times 10 to the power 6 joules. Just be careful with the calculator work. Make sure that you don't forget to square it, the pluses are correct, the subtraction of the potential energy, and that's the end of the sum. So this is a very interesting sum, and it shows the application of how to tackle inclined plane sums. I hope you do well in case the sum come, and I hope that this small video clip has clarified the issue for you. Thank you for watching.